Hello everyone, this is your instructor and trainer Amit Maheshwari. This session we will discuss how we can go and create container in Kubernetes environment. Okay, so first of all, we will be writing the YAML file in Kubernetes to create any resource or any object in Kubernetes. So while writing the YAML file, we need to follow specs, certain parameters we need to provide it into the YAML file. So what are the different standard parameters are there? API version, kind, metadata, spec. Most of the YAML file will in the Kubernetes, most of the uh, things which we are going to create in Kubernetes, they will follow the same set of instruction. So API version, kind, metadata, and spec. Kubernetes has different kind of resources and object which we can create it. As a we will proceed with the course, we will see what are the different kind of resources we can create it. Depending on the kind, API version will be defined. Okay, so Kubernetes resources are divided in API groups. So suppose I want to create a container in Kubernetes. Whenever you want to create a container, it will be named as pod. Okay, so pod is the part of core API group, which is V1. When we want to create a pod, we want to give the name to the pod. The name will come under metadata. And whenever you want to create a container, as we seen it, whenever I want to create a container, I need to provide the image. So under the spec section, the image will come. So API version, this defines the Kubernetes API that we want to use it in the YAML file. You can check it out the API version through command line as well. The command line is kubectl API hyphen resources. Kind, that defines what kind of Kubernetes object we want to create it. Metadata, this is the data that help us uniquely identify the object that we want to create it, such as providing a name to the object. So any kind is generic, is a kind of common noun, and then we provide the name, it becomes the proper noun. Okay. Spec, that defines the state that we want to or create the object from where we want to create it. Okay, all these things will come under the spec section. Now let's go to the pod. So as I told, in Kubernetes, whenever you want to create a container, you will be creating the pod. So pod is a Kubernetes resource which is a smallest deployment unit of computing that you can create and manage in Kubernetes. This is the part of workload API. So whenever I want to create or want to run a workload, I need to create a pod in Kubernetes. Kubernetes cannot directly go and create a container using the Docker command. They will be using kubelet, and through kubelet they will be creating pod. Inside the pod, the container would be running. A pod is a group of one or more container which can have shared storage, network, and specification how to run these containers. While Kubernetes supports more container runtime, also it's not necessary that you use the Docker as a container runtime. You can use containerd, you can use cryo, you can use Docker engine, you can use podman, anything you want, you can use it. Pods type, you can pods that run a single container, pods that run the multiple containers. One container, one pod is the standard module, which we generally should do it. Until unless you don't have any use case, you should not try this thing. In case you can think of a pod wrap around a single container, Kubernetes manage pods rather than managing the container directly. A pod can encapsulate an application composed of multiple co-located containers that are tightly coupled and need to share the resources. When I say need to share the spaces, a pod can contain multiple containers, but they need to share the IP address. They need to share the storage space because pod is the single entity. Instead that if multiple containers are there, so they should be tightly coupled. Basically, one will be the becoming the main container, second can become the helper container. During the lab session, I will explain you in detail. This is a YAML file of pod, API version V1. kind is pod. As I told, depending on the kind, the API version will be decided. Name, you can provide any name. Spec section, you are seeing a list, and list name is containers. And under that, the first container name is coming and the image is coming. If I have more than one container, then second container name will come and image will come. Like that it will come. The command we will use it kubectl to create any Kubernetes resource. You will run the command kubectl create -f and the YAML file name. Once it's done, then kubectl get pods will show you which are the pods which is running it. If you need more details, you will run the command kubectl describe kind of resource, that is pods, and the name of the pod. It will give you the full detailing list about the pod. So we have seen three commands here: kubectl create, kubectl get, kubectl describe, and kubectl delete in case I want to delete the resources. Once the pod, when you run the uh, kubectl describe command, you'll see the event section will come. Under the event section, you'll see the kubelet is pulling the container image, kubelet is creating the container, kubelet is starting the container. So basically, kubelet is a Kubernetes agent which will be talking to the container runtime to create the container, to manage the container, and to start the container. So kubelet is the Kubernetes agent. So API server will send the YAML file to the kubelet, and then kubelet will go and talk to the container runtime. In our case, that would be the Docker, and through Docker they will be creating the image, creating the, sorry, not image, so creating the container, starting the container, all this thing they will do it. If I want to create a multi-container pod, then API version, kind, pod name, everything is same. Under the containers, as I told, containers, this is the list. The first container name, image name, the second container name, the image name. Okay, this is the way you can do the multi-container pod. So pod lifecycle, same like container runtime lifecycle. It can be having pending, running, successful, succeeded, failure, unknown. These are the simple high level pod lifecycle things. Pending is when containers are waiting for something to be scheduled. Maybe they are still downloading the image, the network is not coming up. Running means the container is upgraded successfully and they are running, still running. Succeeded is basically container is running a specific task. When they are completed, they are terminated. It will be mentioning successful. It will never restart. Failed means container are terminated due to the failure. Then it will show you. Unknown means suppose container has started and they have failed due to some reason, and but that reason is not detailed out. Then it will show that thing. Thank you everyone. Let's connect